The universe is a place of profound mystery. Its laws govern everything, from the grand sweep of galaxies to the smallest particles. Quantum mechanics is our best description of this fundamental reality. It reveals a world stranger than we can often imagine. A world of probabilities, superpositions, and entanglement. This strangeness, however, might hold an astonishing possibility. The idea of bringing back those who have departed. This is the concept of quantum resurrection. It is a notion born from the deepest roots of physics. Imagine for a moment that death is not an absolute end. What if the information that constituted a person is not truly lost? Quantum mechanics suggests that information in a fundamental sense might be conserved. This is a cornerstone of the theory that describes the subatomic world. If this principle holds true universally, then the essence of a being might persist. Their unique quantum state, the very pattern of their existence, might linger. It could be woven into the fabric of space-time itself. The challenge, of course, would be to retrieve and reassemble it. This is not science fiction in the traditional fantastical sense. It stems from the very equations that describe our cosmos. Physicists grapple with these ideas at the deepest levels of theoretical inquiry. The notion of quantum resurrection pushes the boundaries of our current understanding. It forces us to question the nature of life, death, and information itself. It is an exploration into the ultimate fate of complexity and consciousness. It represents a journey to the very edge of what we currently deem possible within physical law. So, what are we truly talking about here? We are exploring whether the fundamental laws of physics permit such a feat. Could the universe, in its intricate quantum dance, allow for the reconstruction of a once-living entity? This essay will delve into this extraordinary proposition. We will look at the theoretical underpinnings. We will consider the immense, perhaps insurmountable challenges. And we will ponder the profound implications for humanity. It is a quest for understanding our place in the cosmos. At the heart of quantum mechanics lies a powerful principle. It is the conservation of quantum information. This idea is quite profound in its implications. It suggests that information, in its quantum form, cannot be truly destroyed. It can be scrambled, dispersed, or become incredibly difficult to access. But it is never completely erased from the universe's ledger. Think of it like a cosmic accounting system that never loses a single entry. Every interaction, every event, leaves an indelible quantum trace on the universe. Now consider a human being. We are complex systems of particles, intricately arranged. Our thoughts, memories, our very essence are encoded in the state of these particles. This is our unique quantum information, a fingerprint of our being. If quantum information is conserved, what does this mean for consciousness after death? It implies that the information defining an individual isn't annihilated. It merely transforms, becoming part of the universe's vast information tapestry. It's a comforting yet daunting thought for our transient existence. The implications for human consciousness are staggering to contemplate. If the information defining you persists, could it theoretically be retrieved? This is the crux of the quantum resurrection hypothesis. The universe doesn't forget. It remembers the precise quantum state of every particle that ever existed. This includes the particles that once formed your brain and your body. The information is out there, entangled with the rest of the cosmos, waiting perhaps for a sufficiently advanced understanding to decode it. This principle, known as unitarity in quantum mechanics, is fundamental. It underpins much of our modern physics, from particle interactions to black holes. If it holds true without exception, then the story of a life is not deleted. It is merely archived in the quantum state of the universe. The challenge then becomes one of retrieval and decoding. How do we find this specific set of information amidst the cosmic noise? How do we separate the signal of a past life from the background static of the universe? This is a monumental task indeed. If information is conserved, the next significant question is reconstruction. How could we rebuild a deceased individual from their quantum information? This process is known as quantum state reconstruction. It involves determining the complete quantum state of a system. In this instance, the system is a human being. This is an incredibly complex task, far beyond simple observation. It requires measuring and manipulating quantum states with unimaginable precision, a feat far beyond our current technological and theoretical capabilities. Scientists are already exploring quantum state reconstruction for much simpler systems. They can, with great effort, reconstruct the state of a few photons or atoms. But a human body contains an astronomical number of particles. Each particle has its own quantum properties, its position, momentum, spin. It also has its entanglement with countless other particles. Reconstructing this entire web of information is a colossal undertaking. It would require technology that can map the quantum state of trillions upon trillions of particles simultaneously. Once the complete quantum state is somehow known, how would it be implemented? One idea is to reconstruct the individual in a new biological body. This body could be grown using advanced bioengineering techniques. The quantum information would then be imprinted onto this new blank biological form. Alternatively, the reconstruction could occur in an artificial substrate. This might be a sophisticated quantum computer or a specially designed artificial body. This could potentially offer more control over the delicate reconstruction process. The ultimate goal would be to create a perfect replica of the individual, not just physically, but in terms of their consciousness and memory. The reconstructed individual should, in theory, awaken with their memories and personality intact. They would be, for all intents and purposes, the same person. However, the no-cloning theorem in quantum mechanics adds a layer of complexity. It states that an unknown quantum state cannot be perfectly copied. This presents a significant hurdle. We would need to retrieve the information, not merely create a copy. Quantum mechanics offers another intriguing phenomenon relevant to this discussion. It is known as the quantum Zeno effect. This effect is sometimes poetically described as the watched pot never boils. More precisely, if you continuously measure a quantum system, you can prevent it from changing its state. The act of observation, in the quantum world, is not passive. It actively influences the system being observed. This has fascinating though speculative implications for preserving a delicate state like consciousness. Could the quantum Zeno effect play a role in preserving a reconstructed consciousness? Imagine a consciousness that has been painstakingly rebuilt. It exists as a delicate and complex quantum state. This state could be prone to decoherence, to fading away into randomness. However, if this state could be continuously observed or interacted with in a specific way, it might be stabilized. The quantum Zeno effect could, in theory, lock the consciousness into its desired state. This could prevent its degradation over time. This idea extends to the very nature of consciousness itself in some fringe theories. Some theories suggest consciousness arises from specific stable quantum processes within the brain. If these processes could be maintained indefinitely through a Zeno-like mechanism, could consciousness persist? Perhaps even after the biological processes that normally support it have ceased. This is highly speculative, of course, venturing into realms beyond current neuroscience. But it opens a door to new ways of thinking about mind and matter. For a resurrected individual, the quantum Zeno effect might be crucial. After the immense effort of reconstruction, maintaining that fragile state would be paramount. A continuous, delicate interaction, a form of quantum life support, might be necessary. This would aim to ensure the resurrected consciousness remains stable and coherent. It's a profound thought. The universe, through its quantum laws, might offer not only a way back from oblivion, but also a way to stay, to persist against the tides of entropy. Section 5. A glimmer of past selves, gathering quantum data. Let us consider the practical, albeit theoretical, steps to such a resurrection. The first stage in any quantum resurrection attempt would be information gathering. This is perhaps the most daunting challenge of all, a task of cosmic proportions. The quantum information of a deceased individual disperses throughout the environment over time. It becomes entangled with countless other particles in the surroundings. It spreads like ripples in a vast cosmic pond, becoming fainter and more diffuse. Finding and isolating this specific information is an immense task. Where would this essential information reside after biological death? Some of it might be encoded in the immediate surroundings, the particles left behind, but much of it would radiate outwards into the wider universe. It could be carried by photons, neutrinos, or even gravitational waves. Some theorists, like Leonard Susskind, have explored how information is preserved. Even in extreme environments like black holes, information is not truly lost. The holographic principle suggests information isn't lost, but encoded on surfaces. Perhaps the universe itself has such a boundary storing records. Imagine trying to collect every photon, every particle that ever interacted with a person, then tracing their quantum history back to the moment of death. This requires an almost unimaginable level of sensitivity and computational power. We would need detectors capable of registering single quantum events across vast distances. We would need to account for every interaction, every entanglement that has occurred since the information dispersed. The scale of this detective work is truly astronomical, spanning space and time. The sheer volume of data would be overwhelming, far beyond human comprehension. A human brain alone contains roughly 10 to the power of 26 atoms. Each atom has its own quantum state and a complex history of entanglement with others. Reconstructing this requires processing an amount of information far exceeding anything we currently handle. It's not just about finding the pieces of the puzzle, it's about understanding their intricate relationships. The universe is a good keeper of secrets, and unlocking this particular secret would be its greatest test for any future civilization. Section 6. The Spark of Reanimation, Reconstructing and Activating Consciousness. Once the monumental task of information gathering is, hypothetically, complete, the next stage is reconstruction. The collected quantum data, the essential blueprint of the deceased, must be carefully assembled. This information would then be imprinted onto a new substrate. This could be a cloned biological body, carefully prepared to receive this quantum imprint, or it could be an advanced artificial form, perhaps a sophisticated quantum computer designed to host a human consciousness. The choice of substrate itself presents numerous challenges. The process of imprinting this quantum information would be incredibly delicate. It involves setting the quantum state of every particle in the new substrate to match the original. This means arranging atoms and molecules with perfect precision. It means ensuring all their quantum numbers, spin, energy levels, entanglement, are correctly configured. Any error, however small, could lead to a failed reconstruction, or worse, it might result in a distorted or incomplete consciousness, a mere echo of the original. The precision required is at the very limits of what quantum mechanics allows. Then comes the most mysterious and profound step, the activation of consciousness. If the quantum state is perfectly replicated, would consciousness spontaneously emerge? Would the individual simply wake up, their memories intact, feeling as though no time had passed? This is a profound question that touches upon the hard problem of consciousness. Is consciousness an emergent property of a specific quantum configuration? Or is there something more, some vital spark, that physics alone cannot describe or recreate? Ensuring the continuity of identity is paramount in such a scenario. The resurrected individual must be, in a meaningful sense, the same person. They must possess the same memories, personality, and a continuous sense of self. This relies on the assumption that these are all encoded within the quantum information. If the reconstruction is successful, the person should experience a seamless continuation of their previous existence. But how could we ever be truly certain it's the same consciousness and not merely a perfect copy, a philosophical zombie? Section 7. Beyond the Veil: Ethical Quandaries of Quantum Resurrection. The prospect of quantum resurrection, however remote it may seem today, forces us to confront profound ethical questions. Perhaps the most fundamental of these is that of consent. Can we, or indeed should we, resurrect someone without their prior explicit consent? Death for many individuals and cultures is a natural and accepted end to life. To reverse it without permission could be seen as a profound violation. What if the individual wished to remain at peace, their journey completed? These are uncharted moral territories for humanity. Who would have the authority to make these momentous decisions? Would it be family members struggling with grief? Would it be scientific bodies driven by discovery? Or would governments control such a powerful technology? The criteria for selecting individuals for resurrection would be immensely controversial. Would it be reserved for historical figures, loved ones of the powerful, or those who could contribute specific skills to society? The potential for bias and gross inequality is enormous. Such power over life and death carries immense responsibility. Consider the societal impact if such a technology became widespread. If death becomes optional, or at least significantly postponable, how would this reshape human civilization? It could affect everything from population control to resource allocation on a global scale. The meaning of life, our purpose, and the concept of legacy would be fundamentally altered. Would it lead to societal stagnation as the old guard never truly leaves positions of power and influence? Or would it usher in an era of unprecedented wisdom and accumulated experience? There's also the question of the resurrected individual's rights and place in society. Would they be considered fully human, with all attendant rights? Would they face discrimination or, conversely, an unsettling awe? How would they integrate into a world that has inevitably moved on without them? The psychological toll on the resurrected and on their loved ones who have mourned them could be immense. The ethical landscape is fraught with complexities, demanding careful, compassionate, and global consideration long before it becomes a reality. Section 8. Philosophical Echoes: Identity, Souls, and Meaning. Quantum resurrection doesn't just challenge our technology, it profoundly challenges our philosophy. It forces us to ask fundamental questions. What constitutes personal identity? Is it merely the sum of our memories and our physical structure, all encoded in quantum information? If we perfectly reconstruct this information, is the resulting person truly the same individual who died? Philosophers have long debated these questions of identity, continuity of consciousness, and the nature of the self. This technology would make these debates startlingly real and urgent. Many cultures and religions throughout human history embrace the concept of a soul. This is often seen as a non-physical essence that defines us and survives bodily death. How does the idea of quantum resurrection align with this widespread belief? If a person can be brought back through purely physical, informational means, does this negate the existence of a soul? Or could the quantum information itself be a physical manifestation, or perhaps a carrier of what we call the soul? This could lead to a profound re-evaluation of spiritual beliefs worldwide. The very definitions of life and death would need to be reconsidered and possibly rewritten. If death is no longer a permanent, irreversible state, but a potentially reversible one, its significance changes dramatically. What does it mean to live if the process can be paused and restarted, perhaps multiple times? The finality of death has shaped human art, culture, and our enduring search for meaning. Overcoming it could create an existential void for some, or conversely, open new avenues for purpose and understanding for others. This technology could compel us to find new sources of meaning in our existence. If the fear of oblivion is diminished or removed, what then drives us as individuals and as a species? What becomes important when existence can be extended, perhaps indefinitely for some? The pursuit of knowledge, creativity, connection with others. These aspects of the human experience might take on even greater significance. Or perhaps the sheer vastness of an extended existence could become a psychological burden. Humanity would need to find new philosophical anchors in this brave new world. Section 9. The Dawn of Possibility, Current Limits and Future Horizons. Let us be absolutely clear. Quantum resurrection, as we've discussed it in this exploration, is far beyond our current scientific and technological capabilities. We are only just beginning to understand and manipulate quantum systems on a relatively small scale. The challenges of information gathering, storage, and precise reconstruction for a system as complex as a human being are immense. They are orders of magnitude beyond anything we can currently achieve or even precisely model. This is not a project for tomorrow or even for the next century. However, the laws of physics, as we currently understand them, do not explicitly forbid it. The conservation of quantum information is a fundamental tenet of modern physics. If this principle holds true universally and without exception, then the information is, in principle, available. The ultimate question is whether humanity will ever develop the means to access and utilize it. This would require breakthroughs in quantum computing, nanotechnology, neuroscience, and fundamental physics that we can only dream of today. It is a long and uncertain path. The journey towards such a possibility, if it is a journey we embark upon, would be a long one. It would involve countless small steps, new discoveries, and paradigm shifts in our understanding. Each advance in our understanding of quantum mechanics, of information theory, of consciousness itself, could bring us infinitesimally closer, or it could reveal new, currently unforeseen, insurmountable barriers. Science is a process of exploration, and the map of what is possible is constantly being redrawn by new data and new theories. This is one of its most distant, yet tantalizing frontiers. Ultimately, the pursuit of such an idea speaks to a fundamental human desire. It reflects the desire to understand the universe, our place within it, and the nature of existence itself. It is part of our drive to overcome limitations, even one as profound and seemingly final as death. Whether quantum resurrection ever becomes a reality or remains a theoretical marvel confined to thought experiments, the exploration itself pushes the boundaries of knowledge. It reminds us that the cosmos is vast, and its deepest secrets are waiting to be uncovered. The quest continues.